So we know this, and everyone knows this, and this has been happening now in all our urban cities, 5,000 cities in India. And this continuously persists to affect not only our health, but it continuously affects the human capital that our cities can attract to create the India of the future. We've been told repeatedly this may be in the north due to crop burning, it may be in the west due to industry, etc., etc. But one figure that never comes out is the fact that buildings are actually one of the biggest polluters, and in buildings, offices are one of the largest polluters. The reason also for that has been that offices, very largely today, are all centrally air-conditioned, DG power backed up, consume a tremendous amount of energy in lighting and running the equipment. In fact, there is no bigger energy guzzler today in the entire building space compared to an office building today. Also because office buildings have the highest density of people in them, and it's people that we've been talking about. Some big shift happened when the economy opened up in the 90s. And a lot of the companies that came here came from the northern hemisphere, the west, multinational companies, and they brought in with them a requirement to build buildings that they were used to. Now, those buildings worked well in cold climates or colder climates and worked terribly in our climate. With the net result that the buildings that we built, now those pictures of those buildings that you see, and I'm not going to take any names, just in case there's a developer here whose building I've put up, are from all over India. They're from Jammu, Jaipur, Bangalore, Mumbai, Delhi, and virtually their buildings have no sense of identity. They are, like I said, they could be anywhere, and which is what we defined as an architecture of nowhere. It didn't really matter at the time that these buildings were being put up over the last 2 decades what they would do. With the net result, they become even more energy inefficient. But we weren't always like that. 5,000 years of architecture in this region, pre-India, okay? And these are various buildings, they're not office buildings, but they're various buildings, and you can look at them and you know where they come from. You know what's Rajasthan, you know what's Kerala. And they were fundamentally responding to a condition of limited resources or no resources. No bijli, no pani. How the hell do you make something which is highly comfortable, responsive to the environment, with local materials and local resources? Now, that is where we were. How do you build optimally? And identity comes as a consequence of that. And that was what Indian architecture was really all about. And there is this sort of disjunction that we've been sitting at. And what I'm going to try and do today is to put forward a proposition of what we can really do as a country, as a nation, how we can build our cities, how we can make our buildings as a model for the world to see, not as a dumping yard for buildings that don't belong here for the world to experiment with. Most architecture that I was showing you about, which is traditional, followed a very simple principle. First, at the bottom of that pyramid, you see microclimate creation. So, you step into a fort, a palace, a fort naturally feels cool. And it does that without air conditioning because they know where the sun is, they block it out, they use thicker walls, keep the sun out, smaller openings. And by and large, that microclimate that's created makes the site naturally cool. And you will find that in most historical traditional architecture. If you look at the next one up from there is passive design. Now, all this doesn't cost anything. That's the beauty about it. What passive design really does is it looks at natural ventilation, it looks at various aspects of how a building can cut down its natural energy use, its requirement. We have daylight in our country. There is no reason a single light should come on during the day. That's just bad design. We have a reverse problem. We've got too much light. Our problem is keeping it out. However, if you walk into most office buildings, the lights are on, and they're on all through the day. That should be criminal. Above that is when you start looking at efficient systems and renewable energy. Now, the Western model of how this was thought about was forget the bottom two, let's drive the top two. Why? Because a lot of the green rating systems, what we call green buildings, and there was some talk about it earlier, were lobbied by air conditioning companies. So they were pushing for more air conditioning into the building, albeit highly efficient air conditioning, instead of saying, hey, we don't need it half of that in the first place. And that's what we do really well in India. We've been doing really well in India. We're saying, get the bloody equipment out of the building. We can create buildings that naturally do that. And when we say towards a net zero future, we mean net zero in energy, which means you only consume what you can generate on site. Net zero in water, you only consume that much fresh water that you can get on site. And net zero waste to landfill. Now, we achieved those kind of projects in the institutional space. So we've done that in schools, we've done that in colleges. We've got about 10 of those projects running. Some of those are being studied now by NUS, MIT, ETH, Zurich, the various universities. But we thought, can we bring this to the most complex animal of all, the office building? Before that, we had to bring a lot of science, art, heuristic thinking, scientific thinking into how we're going to hack this, how we're going to hack the office building. So we followed a simple philosophy. We said the building in the new workplace, the workplace of the future, will have to be highly sustainable. But our metrics said that it should consume 50% lesser energy than a green-rated platinum building. So the metric is sound. Two, we said optimization. We said in India, okay, I think Sonali had earlier mentioned that would you pay a higher rental for a green building, assumption being that it costs more. We said we will debunk that myth. Because the Indian way of doing things would be, in the global context, that not only should it be cheaper to run, it should be cheaper to build. Third, it has to be unique. And the uniqueness of that project, of every single office building, has to be responsive to its climate and its context, and yet achieve the metrics of cost. And fourth, which is what we were talking about earlier, livable. And livability defined by putting the user, not the company, at the center of the design process. So it's not my developer who's my client, if it's a commercial building. It's not the company that he's leasing to who's the client. In the thought process, it's the employee of that company who's a ghost. When we make these buildings, that we don't know who that is. Unlike in the earlier days when you would design for a private client. Today we're designing for largely a ghost population. So how do you begin to think about that user, and what is that user really thinking about in terms of how he wants to use the space, or she wants to use the space. The Bureau of Energy Efficiency, this is a slide from the first, sustainability, defines a green building, say platinum, at 90 kilowatt hours per square meter per year. That is the energy consumption. So you take your electricity bill, you divide it by the floor area, and that is what your building is consuming. So it's a very easy number. And it's a globally accepted number. It's called the EPI, Energy Performance Index. 10 years back, we completed this project, Make a Mac City in Mumbai. Very successful project. It is very high rental, one of the highest in India. And that was a green building. But over the years, because we've been measuring our buildings and refining these passive techniques based on traditional forms of architecture, we have been able to pull that down to 25. And that is a reduction of about 70% lesser energy consumption purely by using passive design without spending a penny extra from a green building, globally recognized green building rated system. And that's purely by just following through with what we already knew for 5,000 years. Second, optimization, to prove the fact that we're not hogwashing our numbers. For every single element that runs in our building, so energy performance, daylighting, for smart facades, floor efficiency, structural optimization, air conditioning, including things like travel time. How long does it take a person to go from outside an office complex to his desk? Putting metrics around all of that. So what you see in the middle are conventional benchmarks. We put down the targets, and we said that using integrated project delivery, by bringing all the minds to the table before the design is conceived, we will achieve that. So we will have half the air conditioning installed in the building compared to a green building. We will get a person in under 3 to 5 minutes, depending on the site. You know how difficult it is if you go to any of the IT parks or office parks to get in and get out and park and etc. We said we will define air quality standards that are WHO certified internally. But all of that will be at the same cost of what a conventional building that has been transplanted and placed over here, while we will create a building, like I said, from an Indian perspective, but that will work for the global context. Third, like I said, uniqueness, highly responsive to its environment. And fourth is livability. The millennials, big issue. I mean, we face it in our practice as well. What are they really looking for? And we figured that the most important thing that offices have to deliver to them is, other than what is inside the office, is what is outside it. So placemaking, by building smart environments, putting the user at the center of the design process. So in a lot of the projects that we've done, we bring in art and culture to the outdoor space. We bring in great microclimate so the outdoors become usable. We try and fight pollution, which I will show you in some of the projects, in creating these outdoor areas and converting outdoor spaces into workspaces. Breaking the box, getting people out, connecting the umbilical cord between desk and person, and extending that to the larger environment. So very quickly, I'm going to go across to a very different kind of building, which is the Surat Diamond Bourse. And this story is an extremely interesting story because 4,000 diamond merchants came together in a very, very strong Indian Gujarati style and said that as a cooperative, we'll make this building. And of course, they'll make it in Surat with one agenda, that the Bharat Diamond Bourse, which is in Bombay, is dying because second, third generation Saurashtrians don't want to come and polish diamonds for 25, 30, 35,000 rupees a month. So they thought they'll just move the whole bloody thing to Surat, where quality of life will be far better than Mumbai. Because of these 4,000 offices, they also gave us another directive. They said that all these offices have to be interconnected. So it can't be separate buildings, it has to be one building. And we asked them, why? Aren't you all competitors? They said, yes, but we can work as 4,000 different offices, from the very smallest office, which is about 200 square feet, to the largest, which is about 5 lakh square feet, so that any person who has to do anything with diamonds, this will become the destination for them. They can also operate as one single organism, because they will cooperate if the order is that large. Right? So the building is 70 lakh square feet, houses 70,000 people in one building. It's the world's largest office building. It's twice the size of the Pentagon, or the official size of the Pentagon. We know it's 35 lakh square feet. Heaven knows how many more floors they haven't told us about. But it's twice the size of the Burj. It's the largest one. And these guys, okay, most of them are very simple people. And they didn't faze them that they're going and making a project of this size and scale. However, what worried us was, how do we move these 65, 70,000 people from one building in under an hour? So when they come to work and when they leave from work. And that's more capacity than emptying a stadium. A stadium is around about 40 to 50,000 people. That's more capacity than an airport. It's the highest movement capacity in the world. 70,000 people in 1 hour. Because along with that comes 10,000 cars. Along with that comes 20,000 motorcycles or two-wheelers. So we sat down and we put a metric that was defined about how long does every activity take when a person comes from outside to inside. A pedestrian, someone who comes by car, someone who comes by public transport. How long does it take for security? Because this is a high secure zone. How long does it take to park the car? How long does it take to walk to a lift? And based around all of this, we came up with a plan that we will do this in under 10 minutes. And we set up the entire master plan, or the design, the core of the building. The building has been designed like a skeleton, like your vertebra at the back, which is the easiest way to disperse and accumulate people. So the whole design is based on the way the human body disperses and collects blood through an arterial system with the spine in place. What we also decided to do was, how do we take this animal of 70 lakh square feet, 7 million square feet of a single building, and what is it that we can do to bring the consumption down? So we relied on a very, very old idea that again comes from traditional architecture, that hot air rises up and cool air comes in. It also comes from the other idea of, if you see the Kerala board, which is the hyperbolic paraboloid, where if you're sitting in it, and it's very humid in Kerala, but you're very comfortable in a houseboat without air conditioning, because it accelerates the wind through. That's called the Venturi effect. And none of our guys were doing this who were building boats because they knew the physics. They were doing this simply because they were relying on wisdom, something that is the most uncommon part of how we live our lives today. So we designed this whole system where about half the building works on natural ventilation by naturally moving wind through the spine of the building and up across the courtyards. So that's the building when we designed it last year. It started construction. Now, Amitabh Kant tutored, very proud, Make in India, world's largest single building, made by Indian architects, built by Indian contractors. So they gave this to a contractor which no one had ever heard of. I mean, it's not an L&T, it's not a Shapoorji, it's not a Leighton, it's not a Samsung. And this is the next largest building that this person had ever done. I mean, we had never done something of this size and scale before. His next largest size building was 5 lakh square feet. And the man took the project, and we're in December. We started in Jan last year. He's close to completing the project already. He's going to hand over the project next year, by the middle of next year. And that's the speed and pace. 150 lifts, 80 cranes. I mean, the numbers are staggering. That's the project coming up. It's got the world's largest installation of radiant cooling. Radiant cooling is essentially structural cooling. So you cool the concrete, because the problem with standard air conditioning is that you cool the entire volume of air, and with that you get cool. With radiant cooling, it just comes and hits you directly. It doesn't cool the air, it cools the human body. And that's, so it can be naturally ventilated. Half the building is, works of that system. So compared to where we were, we have a 15% saving on CapEx and a 50% saving on OpEx. And that is what we had started with, to prove that green buildings are actually cheaper to build. It never made sense to us. If it's green, you're consuming lesser energy. If you're consuming lesser energy, you're using lesser air conditioning. Then what is costing more? Because you're taking the air conditioning, the DG sets, the transformers, everything is reducing. So that's the one. What is interesting also about this project is that it's led by an all-woman team. Okay, so Indian female architects. Okay, so our office is, we've done this since we started as a startup for 20 years back. It has always been 50-50 across men and women, across all levels, with zero pay parity. The team that is leading the world's single largest office building is all women-led. The landscape architects, the engineers are all women-led. And that makes us something really proud of. And this is something we can tell the rest of the world, that we are the first, we can solve gender parity. And there are ways around that. And that's what leads to a different form of thinking. This sort of male-dominated form of brutal architecture needs to end. We need a finally more collaborative, environmentally, ecologically sensitive, parallelly processed in the mind form of architecture. I think, so I'll go through this very quickly. I know that that thing is showing my times up, but that's not my fault. They told me 30 minutes, then someone told me 25, then someone told me 20, and they put a 15. So in a sort of very Indian evolutionary way, I guess that's how time works. So this is a project that we're doing, again, it's a mixed-use development. It's in Calcutta. It's about 3 million square feet. It's coming close to completion. But I'm not going to take too much time because I am out of time. But the main part I want to bring about here is on contextual identity. Calcutta is extremely rich in art, heritage. What we did was we collaborated, and I'll skip past the master plan. We collaborated with the local artists, and we collaborated with the local sculptors. And the entire, now this comes to placemaking for the millennials, the entire horizontal plane of the site and the vertical plane, the facade, are being crafted by local artisans. We worked with them, we designed for them. So it's essentially an open air cultural center with office buildings as part of it. I'll skip past that. So that's the artwork that was done, and Sonali did some of that artwork. She's sitting here. And what you see on the right-hand side are the local artisans. Office buildings, can do a lot. They can do a lot. This is a 100-meter high mural. And this whole project, including this convention center, this is the script, the Bengali script, which has been cut into stone and displayed, bringing back culture and identity to this project. Now that's the world's largest, longest, it's a 400 meters long, 100 meters high. It's the world's largest urban art billboard, sculpted by local artisans living in villages, brought to a global platform. The project went on to win the best commercial building at the Cityscape Awards in Dubai, an award which ITC has shared with the local artisans. And that's the connect, that's the Indian perspective in the global context.